So I mean, I guess before we get into the zeroth dimension, we can just talk about what a dimension is. I think we did get into this in like a higher dimension episode, but we can definitely like recap, right? Because a dimension is a way of thinking as a direction of travel. So if in a point, there's no direction that you can travel, so you have zero dimensions. On a line, there's one direction that you can travel. It's back and forth. That's basically one direction, right? Technically, like you can just walk in front and walk backwards, but collectively, that's one direction that you're traveling in. Hence the name one dimension. So the dimension term basically simply stems from, well, how many directions can I travel in?
But here's an actual better way to understand dimensions, is that to represent a point in a dimension, right? The amount of information that you need is the dimension that you're in, essentially. If you're in one dimension, you just need one piece of information. And if we just model like the real number line and we give every point a number, then all you need is one number and you say, here I am, right there. If you're in two dimensions, you need two separate numbers, right? And this has to do with the directions, right? You set your axes. Usually it's easiest to make them perpendicular to each other. And then you just say, I am this far along the X and this far along the Y. And then you can basically place any point in two dimensions. And then the same thing goes for three dimensions. You need three pieces of information and all that stuff. And what's even more interesting is that you don't even have to describe your point in like rectangular coordinates. For example, you can do it in polar coordinates, where in two dimensions you need a length and an angle. And that's still two pieces of information, and you can actually still determine like the position of any point. Yep. When you get to three dimensions, you still need three pieces of information, but there are different ways of doing that. You can do rectangular, which I described earlier. You can also do spherical, where you need a length, basically a distance from the origin, and then two angles. Or you can do cylindrical, where you need a distance from the z-axis, an angle in the xy plane, and then a z height. It's,
Yeah, so all of this would be a lot easier like with visual aids, which unfortunately we do not have right now. But I think the two-dimensional case made a lot of sense with polar angles, because you're just imagining some distance and you're imagining some angle from the x-axis, right? We always do it from the positive x-axis. And then in three dimensions, you can really generalize it to some interesting stuff, right? Because then you have that third dimension. So in three dimensions, much like, for example, so the reason it's also called spherical is because it is most used and most helpful when you want to describe, well, a sphere. So take the Earth, for example, right? If we wish to describe the Earth or any point on the Earth, like let's say the center of the Earth is the origin in this three-dimensional world, and we wanted to represent any singular one point on the Earth, anywhere, how would we do it? Well, the first dimension, right, the distance from the center will simply be, well, the distance from the center, right? The second dimension will be your latitude. We already know our latitudes and longitudes on the Earth. And our third dimension will be our longitude, right? So we have some direction that tells us, well, how far are we from the prime meridian? So in terms of angles, right, which is Greenwich. So in terms of angles, how far are we from the prime meridian? That will tell us one of our dimensions. The other dimension will tell us, well, how far are we from the equator, right? Are we up? Are we down? So using these three numbers, are we up? Are we down? That's a pretty poor way to describe it, but you know what I mean. But using these three variables, we are able to describe any point on the Earth. And remember, the spherical coordinates, again, are most useful when we're using a sphere. So it's so simple to describe any point using latitude and longitude because our Earth is a sphere. If our Earth was like a rectangle or a square, which I know it's not possible, but hypothetical, it would be a lot harder to represent it in terms of spherical coordinates, and we would use, well, rectangular coordinates, right?